Hello everyone, in this video I'm going to guide you to use CSV Finder to explore the CSV data in analysis of plasmid resistance island in thousands of genomes from Escherichia, Salmonella, and Klebsiella. So first you will see such 4 files in the folder. First, please open the README file, and in this file, the content of each file will be explained. And we have the CSV result from this MAN file called CSV AMR .csv file. This is the result file from CSV Finder. And as a supplementary file, which is this info csv.amr.fasta. In this file, it contains the authorlog information of all the protein families, which I construct from the thousands of genomes. And the last file, which is the csv.data.tsv, this is the file which provided for you to retrieve the sequence of each CSVs from the genomes. Please do not open this CSV file in Excel because it is quite large, about 2.2 gigabytes. And first, we need to set up CSV Finder. We switch to the GitHub page. So you search CSV Finder on GitHub, and you enter this page. So CSV Finder is the software to find the conserved collinear syntenic blocks in different genomes. And first, we need to download the CSV Finder. So you press here, and you can download the latest release from this page. And before you install CSV Finder, you need a Java runtime environment. And once you set up your CSV Finder, you will have such a graphical user interface. And we first import the result from the previous folder. You click File Open, and you select this CSV AMR.csv file. This is the result file, and you click Import. This result file is quite large, so you need to wait a few minutes until it completely loaded into CSV Finder. I have already previously loaded this result file in the current CSV Finder session. And now I gave you one example to find a piece of a resistance island, including 2 AMR genes. The first one is the beta NDM1 gene, and this gene was clustered into gene family AMR08634. And the second AMR gene, which is the BLE gene, encodes resistance against bleomycin, which was clustered in the protein family MR08703. Right? To find all the CSVs I found in the genomes, including this pair of antibiotic resistant gene. So I click on this button filter, and it will open up a new window, and you could input the protein family name, the 2 protein family name here, into this small window, and you click on Apply, and the CSV Finder will search for all the CSVs, include this pair of genes, and I have already found those. For example, it's here. And firstly, this will be the first look of the result, which includes all the CSVs, including that 2 AMR genes. And it is randomly listed out here but once you click on any of the AMR gene, double click it, and all the CSVs will be sorted according to the gene which you click it on. Yeah, so this is all the CSVs found conservatively in multiple genomes. And here the CSVs are clustered into CSV families in this part, and in the main part in the middle. So here list out all the CSVs from the first CSV family, and the first column is CSV ID, the unique ID for each of the CSV in this result file, and second column is length, so how many protein coding gene in each of the CSV, and then there's a score, and next is instance. This instance is a number of genomes contains this piece of CSV, and the next is all the protein families in this CSV. So I gave you further example how to find the specific CSV contains the pair of AMR genes, and which also matched to a known transponsible element TN125. So this is the CSV, and I double click it, and you see all the CSVs now sorted. And in this window, you see the CSVs include the pair of ARGs and several other genes encoding different functions, including chaperoning complex and S91 family transponses at the end of the CSV. And next, you can see here this E1037, which means this CSV is found in the genome of an E. coli genome, and with genome ID number 1037. And next, you see here there's a P2435, which means this CSV located in this genome and further in a plasmid with plasmid number 2435. And you further see the coordinate of the CSV in this specific plasmid start from 25. So and the CSV count the protein coding gene, the CDS, start from 0. So actually in the in this plasmid, this CSV would start from 26 to 33. Now I will show you how to retrieve the sequence of this specific CSV from the plasmid 2435. So we go back first to the folder. We are going to use this CSV data.tsv file. Yeah, first I will introduce you the structure of this tabular file. This tabular file includes all the information of each protein coding genes in each of the replicons, either chromosome or plasmid. I give you one example as for the first row. So this is a protein coding gene located in E. coli genome 12 and in chromosome 13. And this is the first protein of this chromosome. It has been clustered into a protein family 5538, and this CDS located on plus strand start from this position and end at this position on the DNA sequence, and it has a local stack of this, and it has a non-redundant ref-seq ID, and it has a name. It's a DOOF family protein, and the chromosome has a ref-seq accession number, which is this, and it is a chromosome replicon, and the genome has a ref-seq accession number of this, and it is from Asia strain and with the strain name. So this is the structure of the data file we are going to use. And now we are looking for the specific CSP in the plasmid 2435. So we use grep plasmid 2435 and on this data. Yes, and now we have all the protein coding genes on this plasmid, and the CSP starts from 26 until 33. Yeah, and we can have a look back to the CSP finder view. So the 2000 plasmid 2435 start from 26. CSP finder count the protein coding gene start from 0. So this is 26. And end at 33. Okay, so this is the end of this guide, and I hope you have fun with exploring this CSV data with CSV Finder. Thank you.